Okay, so we know that there's possibly only 3 that will work right here because we have a power of 3. But gosh, which one? Okay. Well, what you're going to do is you're going to focus on the integers, okay? You're not really going to want to mess with, say, the 4/3, are you? Do you want to start with that one? No. So we want to kind of take the easy road out of here, and that would be to choose one of our integers as a factor, all right? And we're going to do, let me find it. We're going to use our synthetic division that we practiced on our warm-up before you guys went on break to decide if, in fact, we do have a 0. Okay? And we're going to use our remainder theorem. So, for example, is 2 a factor of 4? Is 2 a factor of 4? Yes, because 4 divided by 2 would give you a 2 with 0 or no remainder, right? What would happen if I divided 5 by 2? What would I get? I would get a remainder, wouldn't I? I would get a remainder of 1. Okay? So would we say that 2 is a factor of 5? No, because our remainder was not a 0. So we're going to use our synthetic division and to check these zeros to see if, in fact, we do get a 0 for a remainder. If we do, we know that we will pick that one out of, how many choices do we have up here? A lot, right? So if I want to choose one, I'm going to try to focus on one that's pretty simple. In this case, I'm going to go with, I think I'm going to try the factor of x plus 1. I'm going to try that one. Is x plus 1 a factor of the 3x cubed plus 8x squared minus 7x minus 12? Well, if it's a factor, I know that if I divide it, I should get a remainder of 0, just like if I divided 4 by 2. All right, so we're going to set this up. So we're going to set it up using our synthetic division. So if I have x plus 1 as a factor, what's my 0? Minus 1, or negative 1. So we would set our synthetic division up using our negative 1. So set that up. You've got your coefficients to put in there. You have your 3, your 8, your negative 7, and your negative 12. Did we need any zeros in there for place value? No. We went from cubed, squared, first power to constant. I'm going to box in my remainder so I know if I'm getting a 0 or not. Okay, how do we start this thing? Bring down the 3, and let's go. So I bring down the 3, I multiply that by the negative 1, and that gives me a, I move that up, and then we do add, and we get a, and then we repeat our process. So that would be, give us a, okay. And then that would give us, I'm going to repeat. That's going to give us 12, positive, yeah. And what do we get? 0. Is that what we wanted? Yes. Okay. So we get a 0, so we can say, in fact, that x plus 1 is a factor. So let's go ahead and bring that down. Now, what do we have left? We have, this is what we have left after we have factored that out. So we need to bring that, put it back in the form of a polynomial. So this would be 3x to the what power? Square. Remember, we always go one less than what we started with, right? We started with a cube. We've basically taken an x out, so now we're down 1. 3x squared plus 5x minus 12. Okay? Now I've got something I can work with. What could I do with a 3x squared plus 5x minus 12? Yeah. See what you can do with that? Okay, so your 3x squared plus your 5x minus your 12. You can use your x method. That does work. you would get a negative 36 and a 5. The factors of negative 36 that add up to 5. 9 and negative 4. And then we need to take that a out of there, so we divide it by 3. Reduce the 9 and 3 for 3. So we end up with x plus 1 times x plus 3 times, remember your denominator becomes the coefficient, 3x minus 4. And so for our x's, we would have negative 1 here. Here we would have negative 3. And here we would have positive 4/3.